Hi, good evening, everyone. This is Shefali Singla, and in this session, we are going to cover the remaining applications of attribute closure, followed by minimal cover. When we were discussing previous year gate questions or the questions from the other exams, we have seen that lot many questions have been asked from this concept directly. So basically, we just need to have the basic idea of these concepts, and we are good to go. So before starting with the new applications, first of all, we'll be discussing the questions which I posted in the group in the PDF format. So that were the questions that you had to try, and after that we will start with the next applications. Okay, so I gave you the questions on the basis of finding the candidate key prime attributes and the non-prime attributes. Why I'm giving you these many questions as the assignment? This is because uh, the concept of normalization is based on identifying the keys, prime attributes, and the non-prime attributes. So that's why we are doing this much practice. Okay. So this was the first question. In case, guys, you have any doubt or any query, please write that in the chat section. Otherwise, I'll assume कि आपको सारे concepts समझ में आ गए and we'll go with the flow. Okay. Right. So this is the first assignment question. Just tell me that what would be the keys here. Starting कहाँ से करेंगे? That is from the left hand side of the first functional dependency of the given dependency set. So here we are given that A determines B. So I'll find out A closer. जो लोग लाइव सेशन ज्वाइन कर रहे हैं guys, can you tell me that how many candidate keys you are getting for this question? इस क्वेश्चन में आपको कितनी कैंडिडेट कीज मिल रही हैं? A closer, A will be determining itself in the given dependency set. We have A determines B, so A is determining B, B is determining C, so I'll include C, C is determining D, so I'll include D. And there are four attributes in the relation R, so we can say that A closer is determining all the attributes of a relation, so this is a super key. But here we are getting a single attributed key, or we can say that simple super key, जिसका subset possible नहीं है. So directly I can call this as a candidate key because subset is not possible here, right? So we have got one candidate key, that is A, and we know that prime attributes are the key attributes. So A will also be the prime attribute. एक से ज्यादा कैंडिडेट की आएगी कोई पॉसिबिलिटी है या नहीं है? आपको सारी ऑप्शंस चेक करने की जरूरत नहीं है. जस्ट चेक आउट कि जो आपके पास प्राइम एट्रीब्यूट आया है, इज दैट प्रेजेंट ऑन द राइट हैंड साइड ऑफ एनी डिपेंडेंसी. इसको रट्टा मारने की जरूरत नहीं है, बिल्कुल सिंपल कॉन्सेप्ट है. अगर कोई एट्रीब्यूट है जो ए को डिटरमाइन कर रहे हैं और ए बाकी सारे एट्रीब्यूट्स को डिटरमाइन कर रहे हैं, तो ऑब्वियसली बात है कि जो attribute D here, it will also be determining all the attributes of relation. So this is the idea behind this logic. So we can replace this A with the attribute D. So I'm replacing this A with D. So I'll try with D closer. D closer will be determining itself. D is determining A and A is determining all the other attributes. D is already included, so इसको मैं दोबारा include नहीं करूँगी. And since here on the left hand side we have a single attribute, so directly we can say that it's a candidate key. जब एक से ज़्यादा attribute है तो हम directly candidate key नहीं बोलते. उस case में we call that as this super key, and then we have to check for the subsets. Okay. Next one is, now D is also a candidate key, so it's a prime attribute. Check A or D or a combination of both is present on the right hand side of any dependency. Yes, D is present on the right hand side of C, so I can replace this D with C. C closer will be C is determining itself, C is determining D, and D is determining all the other attributes of a relation. So C will also be a candidate key. So we are getting here one more candidate key. So prime attribute is C as well. Now same concept will keep on applying till we reach the end. End कैसे पता चलेगा? जब हमें कोई option ही नहीं मिलेगी, that means we have reached to the end. Now replace this C with B because C is present on the right hand side of B. So I'll be replacing this C with B. B closer comes out to be B is determining itself, B is determining C, और C बाकी सारी attributes को determine कर रहा है. So obviously B is also a candidate key. So I'll include B in the set of prime attributes. Now see, B is present on right hand side of A. So I'll try to replace B with A, but we have already covered A closer. There is no other possibility, so this will be the end. So in this case, we are getting four simple candidate keys: A, B, C and D. Same are the prime attributes. Relation में चार ही attributes थे, चारों attributes prime attributes है. This means that in this case there will be no non-prime attribute. There is no non-prime attribute. Is this clear? So basically this is how we get an idea that if more than one candidate key, or are there any candidate keys possible. Is this clear? Guys, quickly give me the confirmation if it's clear. Hurry up. It will be great if you guys will be responding, because जितना ज़्यादा interact करोगे, जितना response करोगे, जितनी queries पूछोगे, more clarity you will get over the concepts. Okay, so there is a relation R with 6 attributes A, B, C, D, E, F, and we are given with a functional dependency set, and we are supposed to find out the candidate keys, prime attributes. If you have correctly found the candidate keys, all the candidate keys, then easily you can determine the prime attributes and the non-prime attributes. So the main concept is identifying the candidate keys correctly. Okay, so from where we need to start, we'll start from the attributes which are present on the left hand side of the first dependency. So that is AB. I'll find out AB closer. AB will be determining itself. AB is determining C. C is determining D. D is determining E. E is determining F. Since it has determined all the attributes of relation, so I'll call this as a super key, not minimal super key or candidate key directly. Can you tell me the reason why in the first instance I'm calling this as a super key, not the candidate key? I've discussed this reason many a times. कल काफी बार बताया है मैंने आपको ये concept. So since it is determining all the attributes of relation, but still I'm calling this as a super key, not the minimal super key or the candidate key. Anyone? Waiting for your response. Hurry up. This is because proper subset of AB is possible. जब आपके पास एक से ज़्यादा attributes होते हैं तो proper subset possible होता है, and if the proper subset is determining all the attributes of relation, so we cannot call the super key as a candidate key, because the candidate key is the minimal uh, super key, right? That means a candidate key always contains the minimum number of attributes which are required to identify or to determine all the attributes of a relation. So let's try with A closer, because AB के proper subset क्या बनेंगे? A, and other possibility is B. So I'm finding A closer. A will be determining itself, खुद को determine करेगा, अकेला A और किसी को determine नहीं कर रहे, so this is not possible. This cannot be a candidate key. Let's try with B closer. B alone will be determining itself, and that's it, right? So this means that no proper subset of AB is determining all attributes of relation. So this is the minimal super key, or you can call this as a candidate key. So we have got AB as the candidate key. Key attributes are A and B. Now check if any of the prime attribute is present on the right hand side of any functional dependency. कहीं पे आ रहे right hand side पे B is present on the right hand side of F. So I'll try to replace B with F. I'll get AF closer. It will be determining AF. Yes. F is determining B, AB is determining C, C is determining D, and D is determining E. So it's a super key, not candidate key. अभी नहीं बोलेंगे. A closer we have already checked. Check for F closer. F closer is determining F. F is determining B. That's it. So this means that no proper subset of AF is determining all attributes of relation. So AF is another candidate key. F is also a prime attribute. Now F is present on right hand side of E. So I'm replacing this F with E. I'll find out AE closer. AE. AE is determining AE is determining F. F is determining B. AB is determining C, and C is determining D. Check for the proper subset E closer. It's determining E, F, and B. Yes. So proper subset determine nahi kar rahe. So AE is another candidate key, or you can get a hint here. C को determine करने के लिए AB दोनों चाहिए, right? So A is the mandatory thing. Now E is present on the right hand side of D. So I'll try with AD closer. AD. D is determining E, E is determining F, F is determining B, and B is determining C. D closer is determining D, E, F, B. That's it. So AD is another candidate key. D is also a prime attribute. E was also a prime attribute. Now replace this D with C, same concept. जब तक हमें options मिलेंगे, we'll keep on exploring the options. C is determining D, D is determining E, E is determining F, and F is determining B. So we'll try with C closer, C, D, E, F, B. None of the dependency is determining A. तो यहाँ से आपको एक hint मिल गया कि A will be the mandatory attribute of a candidate key. So AC is another candidate key, and C is also a prime attribute. Now C is present on right hand side of AB. We have already explored it. That means there are no other options. So in this case, 5 candidate keys are possible, and all the attributes of a relation, that is A, B, C, D, E, F, all these attributes are the prime attributes. So again, in this case, we are not getting any non-prime attribute. So this set is equal to 5. Make sense? Next one. Here also you have to identify the candidate key. This is the last question from the assignment, I guess. So there are 5 attributes and you have to identify a candidate key. So we'll start with, from where should I start? We'll start with AB closer. So here we are getting AB. AB is determining C, C is determining D, D is determining E. Now check for A closer. A closer is A only. B closer is B only. So here we got one candidate key, that is AB. अब तो आप फटाफट से आंसर बता सकते हो. Non-prime attribute. Guys, see, when we'll be talking about the normalization concept, I'll not be repeating all these concepts again. अगर आपका doubt आएगा तो मैं आपको ये बोलूंगी कि जिस जो attribute closure application वाली वीडियो है उसको रेफर करो. So better है कि अभी इसको understand कर लो, because if I keep on repeating the base concept again and again, तो हम advanced level पे कभी जा ही नहीं पाएंगे. So it's very important to clear your basics. Okay. Now C, A is present on the right hand side of C. So I'll be replacing this A with C. Let us find CB closer. So it comes out to be CB. C is determining A and AB is determining C. C is also determining D and E. Let's find out with C closer. C closer will be C and A. and also determining D, and D is determining E. This is the C closure, but here B is missing, so it's not determining all the attributes. So we can say that CB is another candidate key and C is key attribute. Non-prime attributes are remaining attributes of a relation are D and E. So D and E are the non-prime attributes. Make sense? Before the break, there was a good response, but after break आपको बल्कि रिवीजन करके कॉन्सेप्ट्स में और क्लैरिटी आनी चाहिए थी, बट उसके बाद हुआ ये कि रिस्पॉन्स भी आने बंद हो गए. Why is it so? Next one. Do you want to try this question? या मैं खुद ही क्वेश्चन दूं और आंसर्स बता दूं आपको? Anyone tried these questions or have you downloaded the PDF? Group में, Telegram group में, I posted a PDF. Have you downloaded it? खोल के आपने पढ़ा है तो आपको ये सारे क्वेश्चंस मिले होंगे, क्योंकि इस सेशन में मैंने बोल दिया था आपको that you need not to note down anything, you just need to understand the concept. I'll share the PDF which will include the theory, questions, everything. कौन से ग्रुप में ये सब? In the Telegram group, right? Okay, so let's see here. AB से start करेंगे. AB closer is determining A, B, C. C is determining D. D is determining E. And all the attributes are determined. So now let's find out the subset closer. A closer will be A. A is determining B. AB is determining C. C is determining D. D is determining E. That means the proper subset of AB is determining all attributes of a relation. So we can say that this is the super key, not candidate key. So candidate key is A. So on the basis of this, we have got a prime attribute, that is A. Now see, if A is present on right hand side of any dependency, A is present on the right hand side of C. So I'll replace this A with C. C is determining itself, C is determining A is determining B, B is determining C is already determined, C is also determining D is determining E. सारे एट्रीब्यूट्स आ गए. सिंगल एट्रीब्यूट है तो सबसेट चेक करने की जरूरत ही नहीं, क्योंकि पॉसिबल ही नहीं. So C is also a candidate key, so is the prime attribute. Now see, if the attribute C is present on right hand side of any dependency, yes, it's present on right hand side of AB, but we have already checked for AB, so that is it. We'll stop here. Non-prime attributes. In total, there were 5 attributes, out of which 2 are the prime attributes. So remaining 3 attributes, that is B, D, and E, will be the non-prime attributes. Yes? So this is the answer for this question. So I was talking about the PDF, where you can find this PDF. This PDF is shared in the Telegram group. This is our official Telegram group, that is Shefali Ma'am Testbook. You can search out for this group, or you can go to the description of this video, and there you'll get a link. Or if you are unable to find it, then just wait for half an hour more, and after that I'll share my screen and I'll show you that where is that link available. Okay, so watch the video till the end so that you get everything. So daily PDF of all the YouTube sessions are shared in this group, so you can download it, and you can also ask your doubts or the queries in this group. Apart from that, you can directly interact with me. You can also participate in the quiz and the polls. Okay, next one. There is a relation R with 4 attributes A, B, C, D, and we are given with 2 functional dependencies. We have to identify the candidate key, prime attribute, and a non-prime attribute. So you know the starting point. Starting point is the attributes which are present on the left hand side of the given first functional dependency. So because at least we need some starting point and we cannot explore all the options. So this is the easiest approach to start with the attributes of the first functional dependency. So here we have AB. So find out AB closer. AB, AB is determining C and BC is determining D. Since here we are getting two addition, so we can say that this is a candidate key. So we have got one candidate key. The struggle is still finding the first candidate key. उसके बाद आपको hints मिलने शुरू हो जाते हैं. So on the basis of this, we can determine the prime attribute. Prime attributes are A and B. Is is there any other possibility of getting more candidate keys? Please write in the chat section. Is there any possibility of getting more candidate keys? No. Reason? Because none of the prime attribute is present on right hand side of any functional dependency. So that's it. So in this case, we just have one candidate key. Non-prime attributes will be C and D. There are two non-prime attributes, that is C and D. Make sense? Next one. Identify the candidate keys. This is the last question for identifying the candidate keys, prime attributes and the non-prime attributes. Candidate key, prime attribute and non-prime attribute. So just identify that what should be the answer or how many candidate keys you'll be getting for this relation and the functional dependency set. We'll discuss one or two more questions of the same concept because here one part is missing. Please write in the chat section that for this relation, how many candidate keys are possible. We'll start from AB, you know the starting point. AB closer. AB is going to determine itself. AB is determining C. C is determining D. D is determining E. So we'll stop here. Since here two attributes are there, so directly I'll not call this as a candidate key. I'll check for the attribute closure of its subsets. So A closure, A is determining itself and alone A is not determining any other attribute. Check for B closure. It's B and B alone is not determining any other attribute. So here we can say that AB is a candidate key. Now, B is present on the right hand side. Prime attributes are A and B. B is present on the right hand side of D. So I'll be replacing this with D. AD closer. पहले मैं इस dependency को use कर रही हूँ. Although you could have replaced A with E. So we'll be getting other option as well. That is EB closer. ED closer like that. Okay. So AD closer will be A. D. D is determining B, AB is determining C, and C is determining D, D is determining E. Check for D closer. D is determining itself, D is determining B, and D is determining E as well. E is determining A. ए बी मिलकर किसे डिटरमाइन कर रहे हैं ए बी मिलकर सी को डिटरमाइन कर रहे हैं सो डी क्लोजर इज डिटरमाइनिंग ऑल एट्रीब्यूट्स ऑफ रिलेशन सो दिस मींस दैट डी इज अ कैंडिडेट की जरूरी नहीं है कि अगर आपके पास पहले कॉम्पोजिट कैंडिडेट की आई तो ऑलवेज यू विल बी गेटिंग द कैंडिडेट कीज देयर इज नो लॉजिक बिहाइंड दिस ऐसा कोई हार्ड एंड फास्ट रूल नहीं है so now if I'm going to try with EB closer I'll be getting EB E is determining A, AB is determining C, C is determining D. Check for B closer already check कर चुके हैं. Let's check for E closer. It comes out to be E. E is determining A and that's it. So this means that EB will be the another candidate key. Yes. Now B is already replaced with D. Did we replace it? Yeah, D. So from there we are getting D as the candidate key. D is present on the right hand side of C, so we can replace this D with C. C will be determining itself, C is determining D, D is determining E, and B, E is determining E. So C is another candidate key, so we'll include this as a prime attribute. C is present on the right hand side of AB. We have checked for AB, and that's it. There is no other possibility, so we'll stop here, right? So in this case, we are getting in total 4 candidate keys, out of which 2 are the composite keys and 2 are the simple keys. All the 5 attributes are the prime attributes. So in this set, we are not getting any non-prime attribute. There is no non-prime attribute for this relation. Correct? Let's move on to the next one. Here, if you see, I'm given with the functional dependency set in which we have 4 attributes A, B, C, D, but in the relation R, E is also there. So what we need to do, if I'll be finding out A closer here, if we are finding out A closer, we are going to get A, B, C, D. Though E is missing. So this indicates that we need to include E exclusively. So in this case, there is no possibility of getting a simple candidate key. So I need to add E as well क्योंकि E attribute E को कोई भी functional dependency cover नहीं कर रही. Okay. So this comes out to be A is determining all the attributes and E will surely be determining itself. So E is one of the candidate keys. So candidate keys may we are getting A, E and prime attribute is A and E. Now since A is present on the right hand side of D, so we'll replace this A with D, we'll get DE closer. यहाँ पे कोई possibility नहीं है, E तो हर एक में आएगा ही आएगा and E is not determining any attribute except itself. So along with E, there will be at least one attribute, right? So this gave you an idea. DE is determining itself, D is determining A is determining B, and B is determining C. So all the attributes are determined, so we got DE. Now D is present on the right hand side of C, so I'll replace this with C, CE closer. This will be CE. C is determining D, D is determining A, and A is determining B. So CE is another candidate key. DC. Now C is present on the right hand side of B. So I'll replace this with B. BE closer. It will be BE. B is determining C, C is determining D, and D is determining A. So BE is another candidate key. B is present on the right hand side of A. We have already covered it. So this is the end. So in this relation, we are having 4 composite candidate keys and all the attributes are the prime attributes. No non-prime attribute is available. ये एग्जांपल अलग से हमने क्यों लिए because sometimes we need to add the attribute exclusively because that attribute is not covered by any functional dependency. uh, that's it. Okay, right. One more similar equation on the basis of the concept that we have discussed in the previous example. Just give it a try. Similar concept. In total, we have 7 attributes here, that is A, B, C, D, E, F, G. But in the given functional dependency set, if you observe it carefully, no functional dependency is covering the attribute G. यानी कि हर functional dependency में आपको G exclusively लेना है. Okay? Just find out all the possible options. If I start with AB closer, so I'll be getting AB AB is determining C, D, E, F. और options check करने की जरूरत ही नहीं है, सारे attributes आ गए except for G. That means here I need to include G as well. So ultimately we'll be getting all the attributes of a relation EF. So ABG will be one of the candidate key. Prime attributes are, from the first candidate key we are getting three prime attributes ABG. Now check any of the prime attribute is present on right hand side of any dependency. A is a prime attribute and it is present on right hand side of BE. So I'll be replacing this A with BE. So here we'll get BE. B is already included. G. We'll find out BEG closer. So it is BEG and it's determining A. A is determining C, D and F. Right? So BEG is another candidate key. So here we are getting one new attribute, that is E. Next, now AB is present on right hand side of F. So I'll be replacing this AB with F. We are getting one option, that is FG closer. F is determining AB, AB is determining C, D, E. So all the attributes are determined. G to आएगा ही आएगा. So F and FG. Now F is present on right hand side of D, so we can replace this F with D. We'll get DG, DG. D is determining F and F is determining AB, AB is determining C, D, E. All the attributes are determined, so DG is another possibility. Right? Now, is there any other possibility? D is present on right hand side of C, so we can replace it with C. CG closer. C C is determining A, D, E, and D is determining B and F. So all the attributes are determined CG. So D is also a prime attribute, C is also a prime attribute, D is present on right hand side of AB. We have already explored ABG. There is no other possibility. So in this case, we are getting five candidate keys, two candidate keys with three attributes and three candidate keys with two attributes. So here, all the attributes A, B, C, D, E, F, G, yeah, all the attributes are the prime attributes. So in this case also, we are not getting any non-prime attribute. So this is all about the different cases of identifying the candidate keys. I hope that this is clear to everyone. Right? यही different cases बन सकते हैं. I have covered all the concepts in very much detail. So I hope there is no issue in identifying the candidate keys, prime attributes and non-prime attributes. Right? If this is clear, then let's move on to the next application. That is the membership test. Basically, what membership test says, membership से समझ में आ रहा है कि we have to check if the given functional dependency is a member of the given functional dependency set. कई बार क्या होता है कि functional dependency directly functional dependency set में given नहीं है, but is it logically implied? कई बार logically imply हो रहा होता है, तो how to find out that? We'll find out the closure of the attribute. जिस भी functional dependency को आपने check करना है, उसके left hand side पे जो भी attribute है, उसका closure find करेंगे. Okay, so here let F be the functional dependency set and X determines F be the functional dependency, and we have to check whether X determines Y is logically implied in the given functional dependency set or not. Okay, so for this, what we'll be doing is the attribute which is present on the left hand side will find out its closure on the basis of the given functional dependency set. Okay, and we'll see अगर closure find करके आपके पास y आ रहा है, then we will say that the functional dependency x determines y is logically implied in the functional dependency set. Very, very simple concept. So let's assume this is the given functional dependency set. आपको एक functional dependency set given है जिसमें 1, 2, 3, 4, 5 functional dependencies are given to you. And we have to check whether F determines E is logically implied in the given functional dependency set or not. For this, what we need to do is we'll find out F closer. Closer आपको find करना होता है. We'll find out F closer. F will surely be determining itself. Now see, अभी तक आपके पास एक ही attribute आया, that is F. So F is determining AB. AB is determining C, D, E. एंड एफ. आपको पूरा क्लोजर फाइंड करने की जरूरत नहीं है, बिकॉज व्हाट वी वांट कि एफ से स्टार्ट करके एफ क्लोजर फाइंड जब कर रहे हैं तो राइट हैंड साइड पे कहीं ना कहीं पे ई आ जाए. सो हियर वी हैव गॉट ई. So this means that F determines E is logically implied by the given functional dependency set. Very good evening, Shubham. So is this clear? So I guess this is one of the very simple application of attribute closure. So here, since F closure is determining E, so we can say that F determines E is logically implied. Make sense? Yes, yes, no, may or may not be. So just you have to check for the closure and you'll get the answer. Next application is we have to identify whether the given two functional dependency sets are equivalent or not. So basically it's the equality between functional dependency sets. So equality और जब भी हम comparison की बात करते हैं, जब भी comparison करना है तो obviously two identities should be there, क्योंकि comparison खुद से या एक ही चीज का नहीं करेंगे, राइट? ग्रेटर हो सकता है, लेस हो सकता है और इक्वल हो सकता है. तो बेसिकली यू विल बी गिवन विद द फंक्शनल डिपेंडेंसी सेट and we have to identify whether both are logically equivalent or not. So let us assume that we are given with two functional dependency set known as F and G, and F and G are said to be equal if F closer and G closer is same. This is one option. इसका मतलब कि instead of finding the attribute closer, I'm finding here the functional dependency set closer, right? That's a very lengthy task, so we won't be following this approach. This is method one to check whether both the functional dependency sets are equivalent or not. This is method one, but very lengthy. We are not going to follow it. So other easy method is we will see जो functional dependency set F है, is it covering all the dependencies of G? अगर F is covering all the dependencies of G and G is covering all the dependencies of F, that means both are equivalent. दोनों एक दूसरे की सारी dependencies को cover कर रहे हैं, so both are equivalent. So there are two cases. If F covers G, यानी कि G की सारी functional dependencies F में logically imply हो रही हैं, and G covers F, that means if all the functional dependencies of F are logically implied in G, then we will say that if both of these conditions are true, then we can say that F and G are equivalent. Make sense? ये समझ में आया? So basically F covers G, logically F में सारी functional dependencies आ रही है, F G को कब cover करेगा? When F is superset or F is greater than or equal to G. And G covers F is possible when we are saying that G is greater than or equal to F. Both the conditions are true means ये कब possible है? A is greater than equal to B, B is greater than equal to A. So this is possible only when F is equal to G. Yes? So this is what we have to check. Logically dependencies कैसे imply करवानी है, that we have discussed now only. So we'll be using this concept. Let's consider one example. Here we have to check whether F and G are equivalent or not. So this is the functional dependency set F, this is the functional dependency set G. So first of all, we'll see if F covers G, यानी कि G की हर एक फंक्शनल डिपेंडेंसी F में लॉजिकली इम्प्लाई करेगी. G में फंक्शनल डिपेंडेंसीज कौन सी हैं? दैट इज A determines BC. So we'll find out A closer. कौन से सेट में फाइंड करेंगे? सेट F में, क्योंकि F को चेक करना है कि क्या सारी डिपेंडेंसीज G की कवर हो रही है. सो A closer in F is A will be determining itself. A is determining B. A B मिलकर C को determine कर रहे हैं. And we need not to check anything else because we want A should be determining BC. So A is determining BC. So first functional dependency is implied. Check for the second one. For this, we need to find out D closer. In the set F, D closer, D will be determining itself. D is determining AC and D is determining E as well. So D should determine A and D should determine E. So this dependency is also correct. So first condition is true. F covers G is true. Similarly, we'll check for the second one, that is if G covers F or not. Are you getting what I'm doing? So if G covers F, basically इसकी जरूरत कहाँ पे होगी? When we are going for the decomposition or we are getting the minimal cover. तो कई बार minimal cover पे question आ जाता है, तो sometimes the people get confused whether it's equivalent or not. So this is the way how you can verify your answers. G covers F, that means every functional dependency of F should be covered or should be logically implied in the set F. So first one is A. I'll find out A closer here. We need to check for A determines B. A closer will be A. A is determining BC. So this means that A determines B is logically implied. A B determines C. For this, we need to find out. Although जब A C को determine कर रहा है तो A B तो करेगा ही करेगा. But anyhow, if you want to find it out, just find. AB is determining C, so this is also implied. D determines AC चेक करना है तो D closer find करो कहाँ पे? G में चेक करना है कि A cover हो रहा है या नहीं. D is determining itself. D is determining AE. And A is determining B. See, what we need, we want to find whether D is determining AC, D is determining A and C both. So this means that third dependency is also preserved. D is determining E, that's also present. So this is also covered. So second case is also true. Since here we can see F covers G and G covers F. So we can say that given functional dependency set, F and G are equivalent. Make sense? So this is about the last application of the attribute closure. I hope that this is clear to everyone. After this, we are going to discuss the concept of minimal canonical cover. Guys, quickly give me the confirmation. Just the last topic left from today's session. Tomorrow, we will be having a marathon session on decomposition of a relation. So in NIC batch also, I was supposed to take the marathon of decomposition of relation, in which we will be covering two concepts, whether the decomposition is lossy or lossless, or it is dependency preserving or not, right? But उससे पहले I had to take the break. So next marathon will be beneficial for the aspirants of NILEC Scientist B and GATE, ISRO, DRDU, and UGC NET. Okay. Again, no confirmation. Okay. So you can expect a straightforward question on the basis of the minimal canonical cover. In fact, we have come across the questions on the basis of minimal canonical cover when we were discussing the previous year questions. So a minimal canonical cover, नाम से ही समझ में आ रहा है, we want the minimum number of attributes and the minimum number of functional dependencies. So basically it is the process of eliminating the redundant functional dependency. Redundant means जो unnecessarily repeat हो रही है, or you can say that eliminating the process of redundant attributes. So if there is any redundant functional dependency or attribute, we have to remove it. So it is the process of eliminating redundant functional dependencies. For example, here we are given that A determines B and B determines C. So A determines C can be indirectly or can be logically implied from these two dependencies. We need not to include this separately. Like if I need to check if there is any functional dependency which is redundant, so for that what we need to do is whatever attribute is present on the left hand side, just take its closer. A closer, A is determining B, B is determining C. So this means that A is logically implied. So if this is not included, we can still determine A determines C. Okay, so we can say that A determines C is a redundant functional dependency. So I can eliminate it, functional dependency. So if I'm going to eliminate it, what functional dependency set we are going to get? It will be A determines B and B determines C. That's it. So this is the minimal canonical cover. Make sure whenever you are eliminating the redundant functional dependency or the extraneous attribute or the extra attribute, then also the meaning of the functional dependency should be the same. That means there should not be any change. अगर आप extra attribute या dependency को remove कर रहे हो, then it should not change its meaning. That means before elimination and after elimination, whatever functional dependency set you are having, both should be equal. Now only we have discussed that how to check आपको अपना आंसर अगर verify करना है. If you are confused, then how you can verify? Let us assume that this is set F, functional dependency set F. This is functional dependency set G. You can verify it how? See if F covers G and G covers F. F covers G, G की सारी dependencies directly F में आ रही है, right? So this means that F covers F, G को cover कर रहे हैं. This is true. Check if G covers F or not. G covers F or not. तो F की dependency सारी G में आ रही है. A determines B is there, B determines C is there. ये तो directly imply हो रहा है. Check for the last dependency. So G में we will be finding A closer. A closer is A, B, C. So from here we are getting A determines C. So this dependency is also preserved. So F covers G and G covers F. So we can say that this is the minimal canonical cover for the given dependency. इस केस में we had other redundant functional dependency. जरूरी नहीं होता कि आपके पास हमेशा redundant functional dependency आ रही है. Sometimes there is a case where we are getting the extra attribute. So A determines B and B determines C is the minimal canonical cover for the given functional dependency set. थोड़ा बहुत idea हुआ? What is this minimal canonical cover? It's simply the process of eliminating the extra functional dependencies or the attributes. Guys, quickly give me the confirmation. Okay. Next one is now we'll be talking about the different cases. In the previous example, we had the extra or redundant functional dependency. Now we'll be covering the extraneous attribute. Extraneous attributes are nothing but These are the extra attribute, extraneous attribute. कैसे और कहाँ से hint लेना है कि is there any extraneous attribute? Extra कब होगा? When there are two or more than two attributes on either side of the functional dependency. जब एक ही attribute है तो obviously we cannot eliminate it, right? So here in this dependency, there is no possibility of having the extraneous attribute because on left hand side and right hand side, we just have a single attribute. But on the left hand side of the first functional dependency, there are two attributes. If logic है, बहुत simple concept है, ध्यान से सुनना. If there are two attributes, यहाँ पे दो attributes है, on either side of the functional dependency और जो भी दो या दो से ज्यादा attributes एक साथ आ रहे हैं किसी भी functional dependency में and it's also a part of some other functional dependency यानी कि AP से मिलकर अगर कोई और functional dependency बन रही है then the attribute which is present on the right hand side is the extraneous attribute. Idea क्या है इसके पीछे? Because if I'll be taking only A will determine B and AB मिलकर C को determine कर लेंगे. So I can say that this B is the extraneous attribute. I'll repeat this one more time. Extraneous attribute कब आएगा आपके पास? जब किसी भी dependency में लेफ्ट हैंड साइड या राइट हैंड साइड पे एक से ज्यादा एट्रीब्यूट है तभी हम बोल सकते हैं कि एक्स्ट्रा एट्रीब्यूट होने की पॉसिबिलिटी है. हमेशा एक्स्ट्रा एट्रीब्यूट होगा that is not true, but there is a possibility of having the extraneous attribute if two or more than two attributes are present on either side of the functional dependency. अब extra attribute कब हो सकता है? When a group of attributes जो आपके पास जहां पे हमें डाउट है कि ये इस साइड पे एक्स्ट्रा एट्रीब्यूट हो सकते हैं उन एट्रीब्यूट से मिलकर अगर कोई और फंक्शनल डिपेंडेंसी आ रही है देन विल चेक व्हाट एट्रीब्यूट कैन बी द एक्स्ट्रा एट्रीब्यूट. और यूजुअली क्या लॉजिकली अगर आप सोचोगे तो लेफ्ट हैंड साइड वाला तो राइट हैंड साइड वाले एट्रीब्यूट को डेटा कर रहे हैं. सो लेफ्ट हैंड साइड एट्रीब्यूट कैन नॉट बी द एक्सट्रानियस एट्रीब्यूट, it's the right hand side attribute. So if I'm going to replace this, I'll be getting the functional dependency. This is the extraneous attribute and we are supposed to eliminate the extraneous attribute. So here we'll get A determines C, B को हमने हटा दिया and A determines B. If you want to verify this, you can easily do that. If A is determining A, B is determining C, agar A determines C, find करना how can you find this? A closer, A is A, B, and AB is determining C. So A determines C is preserved, A determines B is directly preserved. यहाँ पे check करो कि AB determines C आ रहा है. Find out AB closer in this functional dependency set. AB is determining itself, A is determining C. So we can say that AB determines C is preserved, A determines B directly preserved. Since F covers G, if this is set F and this is set G, if F covers G and G covers F, so we can say that they are both the sets are equivalent. So here minimal canonical cover that we have got for the given set. In this case, we just had to remove extraneous attribute and that was B. So minimal canonical cover is A determines C and A determines B. This is the minimal canonical cover. कुछ clarity आई? Guys, please quickly give me the confirmation. Have you got any clarity? एक दो और simple examples करेंगे then we'll discuss one bit lengthy question and on the basis of that we will be coming to one conclusion and that result can be asked in true or false. X, Y, Z determines W. तो यहाँ पे आपके पास single attribute आ रही है तो extra attribute होने की कोई possibility नहीं. Next one. Here we have three attributes. तो यहाँ पे extraneous attribute हो सकते हैं. कैसे identify करेंगे? X determines Y, Y determines Z. So these are the two attributes and ये दोनों एक साथ आ रहे हैं. So Z will be the extraneous attribute. So we got X, Y determines W. X determines Y and Y determines Z. Still we two attributes, and these both the attributes are a part of one functional dependency. So Y is also, we can say that Y is also behaving as the extraneous attribute. So we'll get here X determines Y, W, X determines Y, and Y determines Z. So this is the minimal cover. You get it? दिस इज वन पॉसिबिलिटी. अब कुछ लोगों के माइंड में ये क्वेश्चन आ रहा होगा कि मैम पहले इसे ही क्यों कवर किया है, व्हाई वी आर नॉट कंसीडरिंग x determines y first, so you can consider x determines y. So in that case y will be the extraneous attribute. Other possibility is I'm considering x determines y first, so y will be the extraneous attribute. We'll get xz determines w, and x determines y, and y determines z. So this is also a minimal canonical cover. तो इसके बेसिस पे क्या कंक्लूजन निकला? कंक्लूजन इज मिनिमल canonical cover may not be unique. Result is, note, important points मैंने आपको बोला था नोट करके लिखेंगे, so write note. Minimal canonical cover may or may not be unique. Like here, we are getting two minimal canonical covers for this question. So, solution is, whenever you are given that which of the following is the correct minimal cover for the given functional dependency set, तो आपको minimal cover find करने पे focus नहीं करना है. You have to focus on eliminating the options. Okay, I'll be taking one more example. In that case, we will be getting lot many minimal canonical covers. So it's not a good idea to find out the minimal canonical cover in the exam. Just consider the options and try to find out the correct one. Okay, don't ever go for finding the minimal canonical cover until and unless it's a subjective paper. Agar objective paper hai, then you have to find out the correct option. Okay, here is the next example. AB determines C and A determines C. In this case, is there any extraneous attribute? AB मिलकर C को determine कर रहे हैं और AB से कोई functional dependency नहीं आ रही है. So there is no possibility of having any extraneous attribute. So what will be its minimal canonical cover? Here the idea is अगर अकेला A C को determine कर रहा है, if A alone is determining the attribute C, then what is the purpose of AB determining C? If A is determining C, so obviously AB will also determine C. It's just like if we know the minimum number of attributes which are determining all the attributes of a relation, तो उसके साथ आप number of super keys कितनी भी find कर सकते हो, right? So here we can say that this is the extra functional dependency. Uh, this is redundant functional dependency. It's not playing any significant role. It is not providing any additional information. So this is redundant functional dependency. So we can say that for the given functional dependency set, minimal cover is A determines C. Check करने कर लो. A determines C is implied here. Fine. F covers G. That's true. G covers F. Check करो. If I want to find out A, B closer, हमें क्या check करना है? A B determines C यहाँ पे cover होगा. So I'll be finding A closer here. AB will be determining itself. A is determining C. So AB is determining C. So F covers G and G covers F. So we can say that for this relation function, minimal canonical cover is A determines C. So these are the two, basically two different cases. Either you will be having the redundant functional dependency or you will be having the redundant or the extraneous attribute. Okay. One more case here, A determines B, B determines C. So clearly C will be the extraneous attribute. So here minimal cover will be A determines B and B determines C. Make sense? So this is the minimal canonical cover. So this is about the different cases. Let's solve one practice question and then we'll end our discussion. So whatever the agenda we had for today's session, all the concepts are covered. In case if you have any difficulty or any doubt, please feel free to write in the chat section. Okay, so here not many attributes are there. That means there is a possibility of having the extraneous attribute. Um, A determines B. A, B, यहाँ पे single attributes are so there is no possibility of having the extraneous attribute. A determines B, so B is the extraneous attribute. So we'll get A, C, D determines E, बाकी की सारी dependencies as it is है. E determines D, A determines B, and AC determines D. Still we have three attributes और इन तीनों attributes से मिलकर हमारे पास AC D से मिलकर हमारे पास एक dependency है. So AC determines D. This means that D will be the extraneous attribute. So I'll eliminate it. So we'll get AC determines E, E determines D, A determines B, and AC determines D. Right? Is this clear? Now, if you see here, AC determines E and E determines D, तो यहाँ से आपके पास AC will determine D will be possible. So this is the extra dependency. So we can eliminate it. We'll get AC determines E, E determines D, and A determines B. This is the minimal canonical cover. So in this question, we had a combination of extra attributes as well as the functional dependencies. So this is the minimal cover. Minimal canonical cover. Okay. So this is about the minimal canonical cover. If you want to verify your answer, I have discussed how you can do that. So consider the given functional dependency set as one set and the other one जो आपने minimal canonical cover find किए. Second set consider करो और check करो whether both are equivalent. If both the functional dependency sets are equivalent, this means that you have got the minimal cover right. Okay. I'm giving you one question as the assignment. Just try with this question, okay? And tomorrow we'll be discussing the solution. Or let's solve this. एक ही question देते हैं. After this, we'll be having one more question. So here we have Z determines X. So X will be the extraneous attribute. Y determines Z. So Z will be the extraneous attribute. We get X determines Y and Y determines Z. Z determines X. This is the minimal cover. Okay. I'm leaving this for you to verify whether the minimal cover that we are getting is it equivalent to the given functional dependency set or not. This is the last question and that's for your assignment. I'll share this in the PDF and that PDF will be shared in your Telegram group. Okay. Those who are following the session for the first time, guys, you can subscribe the channel and in the description of this video, you are provided with a Telegram group link. In this link, on the daily basis, I'm sharing the PDF of all the YouTube sessions. And apart from that, you can post your queries and the doubts in this group. If in case you want some guidance or you want to ask anything, you can directly interact with me through this group. And there will be quizzes and the polls in which you can participate and you can keep track of your preparation. Okay. So this is all from my side. Now let me quickly share my screen in order to show you that how you can, I guess it's not coming. Okay. So I hope you all are able to see my screen. So this is the YouTube video that is currently going on. That's good. कि जो लोग सेशन देख रहे हैं and they are liking the sessions and जो लोग new है बेटा click on this like button if you are liking this video and you can share it with your friends. You can post the comments in case if you have any feedback. Okay, now let's quickly go to the description box. In the description, lot many links are given. If you want to attend the master classes, you can click on the masterclass link and you can set a reminder for the same. You can join the NIC Super Coaching batch. If you want to do that, then click on this NIC Super Coaching link that will take you to the Super Coaching batch. So here is the Super Coaching batch. And if you want to join गेट सुपर कोचिंग तो सुपर कोचिंग के लिए सबसे पहले मैंने आपको बोला था टेलीग्राम लिंक सो हियर इज द टेलीग्राम link. Just click on this link and you will be taken to our official telegram group. And apart from that, get super coaching. This is the benefit of the super coaching is you will be getting the recorded sessions, multiple recorded sessions, so it will be completely your choice which faculty you want to follow. ओके यू विल बी हैविंग क्योंकि हर एक का पढ़ाने का तरीका अपना होता है और हर एक का अंडरस्टैंडिंग लेवल भी डिफरेंट होता है सो इट्स कम्प्लीटली योर चॉइस आई एम गोइंग फॉर द फुल कोर्सेज. So multiple full courses are available. Complete course from the Gate Forum and complete course from the Digimentor, Nimbus, and by me and team. So you can see the ratings as well. None of the courses having the rating less than 4.5, and you can see the rating of my course as well. So complete course is available, and apart from that, recorded sessions. So hey, in this you will be getting the live doubt solving sessions. You can see the profile of the super teachers. You can attend the demo classes. You can follow the live series, mock tests, study notes, and again, then we have the pricing. Study notes में बच्चे you will be having the formula notes, which are the shortened notes, which are usually beneficial when your exam is approaching and you have 2 or 3 days or 1 week time. तो उस केस में हम इतने सारे सब्जेक्ट्स के डिटेल नोट्स नहीं पढ़ सकते तो वहाँ पे हम लोग फॉर्मूला नोट्स की हेल्प लेते हैं. सो दीज आर अवेलेबल हियर. यू कैन डाउनलोड इट. अगर मैं अभी डाउनलोड पे जाऊंगी बिकॉज जिस अकाउंट से मैंने लॉग इन किया है इन दिस नॉट इंक्लूडेड द सब्सक्रिप्शन. तो आप यहाँ पे देख सकते हो कि सारे नोट्स के आगे ये लॉक आ रहा है ना. दिस विल बी अनलॉक्ड once you got your subscription. Okay, so you have to click on this buy now button, and same goes with the detailed notes. जितने भी notes हैं, all these things will be available. ये सारी की सारी चीजें आपके लिए unlock हो जाएंगी once you have got the subscription. How to do that? So let's go for the different plans. We have three plans for the gate. That is 3-year plan, 2-year plan, and 1-year plan. 1-year plan is basically beneficial for the students, those who are currently in the final year or they have passed their BTech. Uh, and 2-year plan is beneficial for pre-final year students or the final year students. 3-year plan is beneficial for the students, those who are in first year or second year. Okay, it's never too early to start with the preparation of any competitive exam. आप जितना खुद को टाइम दोगे उतना ज्यादा प्रैक्टिस कर पाओगे, उतनी ही ज्यादा आपको चीजें अंडरस्टैंड करने के लिए टाइम मिल जाएगा. Okay, there will be less pressure, more time you'll be able to give, you can explore the more things and hence it will give you more clarity. और जब clarity आएगी practice करोगे तो obviously it will improve your speed, accuracy and logics, and that is the key for the success. Okay, so here, in order to get the extra discount, you can apply here the coupon. Here is the apply coupon button. Before the payment, you have to apply here the coupon, that is SHEFALIS, in order to get the extra discount. This coupon code is also present in the description. You can get here the coupon code, that is Shefali S. गेट पे मैं ज्यादा फोकस क्यों कर रही हूँ बिकॉज दिस विल हेल्प यू टू प्रिपेयर फॉर अदर कॉम्पिटेटिव एग्जाम्स एज वेल. गेट के काफी सारे प्रीवियस ईयर क्वेश्चंस डायरेक्टली बाकी कॉम्पिटेटिव एग्जाम्स में पूछे जाते हैं. यू थिंक ऑफ एनी एग्जाम and just have a look over the previous year questions of that particular exam और उसको compare करके देखना gate questions के साथ. You will get the idea. So it's always good to cover at least previous 20 year gate papers. So that that will act as a good or important set of questions for the exam you guys are targeting on. Okay, so this is all from my side. I hope that you all have got the link of the telegram group and you must have subscribed for it. uh, So this is all from my side. If you have any doubt or query, you can ask. So tomorrow we will be having a marathon session on decomposition of a relation. So I started discussing the concept of normalization in one of the batch that was for NIC NLET Scientist B. But the major problem that was faced by the students was they were not able to understand that how to do the decomposition. So in session, I'll be discussing each and every concept in detail related to the decomposition so that you may not face any difficulty when we'll be covering the concepts and the questions of normalization. Okay. So tomorrow we'll be having a marathon session. This is all from my side. Time पूछ सकते हो आप लोग. So let me tell you the time for all the sessions will be same, be it the regular class or the marathon session. So we'll start the session at sharp 4 p.m. I'll share the link in the Telegram group as well. So it's very, very important for you guys to join the Telegram group if you want to get all the notifications, notes, announcements, and the questions. Okay. Is there any doubt or query? I guess no. So this is all from my side. Thank you so much, guys. God bless you. Good night. Take care. Enjoy your evening.